Today we are going to continue with proportion, and we're going to be looking at indirect proportion, also known as inverse proportion. So previously we looked at direct proportion. That is when two quantities are said to be in direct proportion if they increase and decrease at the same rate. However, with indirect proportion, this occurs when only one value increases, so it occurs when one value increases when the other decreases, or when one decreases, the other value will increase. An example of that would be the number of people it takes to do a job. So we all know that if you want a job done quicker, you get more people to do it. So the increase in number of people will decrease the time it takes to do the job. So these are the types of examples we will be looking at today. So first example, it takes 2 men 6 hours to dig a hole. How long will it take 3 men? So how long will it take 3 men to dig the same hole? We're going to start out our previously similar working to when we were doing direct proportion. So we're going to set out a little table. So we're thinking about how many men and then how many hours it's taken. So we've got a men column and an hours column. So we're just picking out information from our initial question. So 2 men take 6 hours. We are going to work out how long it would take 1 man to do it, the same job. So because it takes 2 men 6 hours, if one person was going to do it, it would take them double the time. So the time's going to increase, and to work that out, in this case it would double, so we're timesing it by 2. But to get our single value, so 1 man, we take how long it took them, so their last column, and times it by whatever number we have in our first column. So here we've got 6 times 2, which is 12, so it would take 1 man 12 hours to do the job, but we are wondering how long it will take 3 men. So to work that out, we are going to we know it would take 1 man 12 hours to do it, so we're going to take the 12 and divide it equally between the 3 men that we've got to do the job. So 12 divided by 3 will give us 4. And we're finishing off these questions with a little sentence to answer what we're being asked. So final step, writing down your little sentence. It will take 3 men 4 hours to dig the hole. Okay, I'd like you to copy these examples down as we go through as well, so feel free to pause at any point. Okay, let's go through a second example. So for this one, it takes 12 workers 4 hours to deliver leaflets to an area of houses. How long would it take 16 workers to do the same work? So we are dealing with workers and how long, so hours, how long it would take to do the job. So we have got our 2 columns, so workers and hours. Picking out the information from the question that we first have, so 12 workers, it would take them 4 hours, so 12 take them 4 hours. We want to figure out how long it would take 1 worker, so that we can build up to answer our question of 16 workers. So to figure out how long it would take 1 person to do it, we have to take our hours, so 4 times 12. So in total it would take them 48 hours to do that job, but we're trying to figure out how long it would take 16 workers. So our last step, 16 workers would be equal to the total hours, 48, divided by 16. So we're going to take the 48 hours and spread it out evenly between the 16 workers. So it would only take them 3 hours to do that job. So our little sentence, it would take 16 men 3 hours. Okay, we've got one more example. So this was all about, the last 2 examples was the number of people it took to do a certain job. We can also consider it with travel and distance, speed and time sort of style questions. So for this example, a car travelling at an average speed of 56 miles per hour takes 5 hours to complete a journey. How long would it take the same journey? How long would the same journey take at 40 miles per hour? So we are saying that if a car is travelling 56 miles per hour, it takes them 5 hours to complete that journey. And we are eventually wanting to work out how long would it take them if they drove at an average speed of 40 miles per hour, how long would it take them to do that journey? So we're going to start breaking it down into just thinking how long it would take to travel a speed of 1 mile per hour. So we're doing 5 times 56, we're taking this last column, timesing it by the first. So it would take 280 hours if you were travelling at a speed of 1 mile per hour. And then to figure out for 40 miles per hour, we're going to take our 280, divide it by 40 to get 7. And then finishing it off with our little sentence, it will take 7 hours to complete the journey travelling at 40 miles per hour. Okay, once you have those examples copied down, the next slide is going to be a task for you to try of 3 questions. So if you pause the video here and work through these 3 questions, and when you unpause, we will go through the answers. Okay, let's go through the answers. Hopefully you've unpaused now. So first question was, if 6 electricians can wire some new houses in 12 days, how many electricians would it require to do the job in 9 days? So if a certain contractor is needing the job to be done quicker, will they have to hire some more electricians to get it done? So for 12 days, it'll take 6 electricians. So one day, we're breaking it down to one unitary value first. 6 times 12, so in total for 1 day's work it would take them 72 electricians, but we're looking for 9 days, so we're going to take 72, divide it evenly between those 9 days, and it will take 8 electricians to do that. And we're going to finish it with a little sentence, for the job to be finished in 9 days it would take 8 electricians. So well done if you got that. Question 2. Jane can type at 60 words a minute and it took 12 minutes to complete a letter. How long would John take, who types at 48 words a minute? Okay, so words for 60 words a minute, it takes 12 minutes for Jane to complete a letter. Okay, so this is a speed they're typing at, so technically this is a speed. So 60 words per minute takes 12 minutes to complete a letter. So for a speed of 1 word per minute, it would take Jane 720 minutes to complete the letter. But then John types a little bit faster, so 48 words per minute. How long would it take him? 720 divided by 48, 15. So take John, who's a little bit slower at typing, 15. And this should not say Jane, it should say John in our little sentence. So that should say John. Can I type? Maybe. I've not got my pen to write with to hand. There we go. So it would take John 15 minutes to type at a speed of 48 words per minute. So again, well done if you've got that. Okay, last question. A car travelling at 45 miles per hour takes 33 minutes for a journey. How long does a car travelling at 55 miles per hour take for the same journey? So we've got speed and time. So 45 miles per hour will take them 33 minutes to complete it. So if they're travelling at 1 mile per hour, remember we need to break it down to that unitary value first before we can build it back up to what we're looking for. 33 times 45 to give us, it would take 1,485 minutes to complete that journey. So then 55 miles per hour, I'm going to take 1,485 divided by 55 to give us 27. So it will take a car travelling at 55 miles per hour, 27 minutes to complete the journey. So really well done if you got all of or most of those 3 questions correct.